problem for this week contest, week 293 LeetCode contest. It's about finding maximum consecutive floors without spatial floors. So basically there are several inputs here. First is the bottom and top, that is the bottom floor and top floor that Alice actually rented in a building, and then and it is inclusive. It means that floor that is mentioned as the bottom and top are also floor that is being rented. And then we are also given another input. The third input is a spatial, which is an array where spatial index I denotes a spatial floor that L is designated for relaxations, and we are asked the maximum number of consecutive floors without a spatial floor. So let's take an example here. Bottom 2, top 9, spatial is floor 4 and floor 6. It means that 2 and 3 are total of 2 floors that doesn't have relaxation spatial floors, because floor 4 is the starting point, and then floor 5 is the only one in between floor 4 and 6 that has no relaxed floor, so it's one floor. The next is between 6 and 9, so that will be 7 and floor 9 with a total of 3 floors. So in total, the maximum consecutive floor without relaxation is 3 floors. And then the second examples, where we have a bottom of 6 and a top of 8, and this is the spatial one. So there is no floor which is not a relaxation floor, because all floor here are 6, 7, and 8 are relaxation floor. Another thing to notice here, nothing here saying that the spatial floor are in order. So this is example 2, we can see that it is not in order. And then this is the constraints, basically at minimum 1, and it could be pretty large. All value in spatial are unique, but they don't say anything about it is sorted. Actually, we have an example where it is not sorted. So that's the problem. Okay, now what is the tactic? The tactic, let's see. Basically, if you notice that it's about a range, and the range is and what we need is we need to find the range in between. All right. Another thing is the spatial things. So we need to combine the bottom, top, and spatial into a range that we need to check. And to help us check that range, we need to sort the spatial floor. Okay, so let's get this as an example to run our tactic. Okay, so what happened here is we need to make it lay it down bottom, top, and spatial into some sort of a logical list. Okay, then for each of those lists, what we need to do is we need to calculate for the distance in between in sort of way, right? So what happened here, maybe let's put it out like this first. It means first is when it is between 2 and 4, right? So when it is the first check is the smallest one with the bottom, where the delta is, where this is the number of floors. If we consider that will be the first index with the bottom minus it, and then that will be 2, right? But remember that 4 is a relaxation part. The one that really have is 2 and 3. So actually a minus is enough to get the number of floors in between. Wait, that's one I want to want. And then after that is the one in between here. So 6 will be, we need to find the distance between 6 and 4. And that would be also init with +1. Why this one is +1? Because remember that when we considering things inside the spatial, they are actually inclusive, right? So 4 and 6 are relaxation place. So the delta itself is not sufficient. We have to do a wait, not a plus one, negative one. We have to eliminate one of it. So if you notice between 4 and 6, there will be only 5. There will be only one floor. So that's a little bit of the difference in the formulae when we actually considering only things inside spatials. And then the last part will be the top. When we considering the top, which is when it is at the end. So at the end, not only we have to consider the pivot, we also have to consider the top, which the formula will be top minus the value itself, which is 3. And remember, when we adding the top, right? When we adding the top, and the top is not in the spatial list, we don't need to do a -1 there because the top is not in the spatials. What if it is in the spatial? Let's say if it is, there is something like this. If there is something like this, maybe let's make it into another one to separate the examples. If there is something like this, the 9 here, and it's actually the top is part of the flow, it will be 9 minus 9, which is 0. So it couldn't be the maximum values in itself, and 0 means just nothing. So we don't need to be scared in the edge cases. Basically in the edge cases where this is the top and the final value is the same, it will be fine. This formula still works. So up to this point, notice the different cases where when it is the first one, we need to consider the bottom. When it is the last one, we need to consider two things. We need to consider the one before it in the spatial list, and also we need to consider the top. And there is a difference in formula between the one including top and bottom, and the one including only the one -1 in the spatials. Okay, and then let's do another examples using the examples number 2. Okay, so what happens if we do our tactic for examples number 2? So for example number 2, if we try to convert this, first we need to sort the spatials. When we sort the spatials, it's become like this. And when we include the bottom and the top, okay? So the first value is 6 minus 6, which is 0. And then the second values, will be 7 minus 6, and because this is inside the spatials, we have to also -1 on it. So 1 minus 1 is 0. Okay, then 8 minus 7 is 1, minus 1 is another 0. Then this one, 8 minus 8 is 0. So there is 0. There is nothing, no floors that is having no relaxed room, spatial room here. So now that's the tactic. Okay, basically we have to sort it and then logically imagine to lay it down like this between the bottom spatial, sorted spatials, and the top. Then we do these branches of formulae depending on the positions of the index that we are checking in the spatials. So the key point here is to check the things inside the spatials and then take spatial cares when it is at the first index, zeroth index, and when it is at the final index. Okay, so another thing is another edge cases that comes to mind is when it is just by itself. Does this still works? Okay, there is only one floor. If there is only one floor, it means Also another constraint. Oh, there will always be at least one spatial room. That's the good constraint there. It means we don't need to care about edge cases when there is no spatial. Let's say when there is one floor only here, does this still works? So of course the bottom and the top will be itself, right? So the number of floors, first this is what you call that. This is the first zeroth index. So 1 minus 1, 0, right? And then secondly, this is also the last index. So 1 minus 1, also 0. And then that's it. It means there is no floors here. And the previous tactic we used, that still works. Now let's go to the code implementation. So first and foremost, we need to sort the spatial for a spatial list, right? And then after that, we will logically lay it down like this. And in terms of the code, it's just about taking a spatial case when it is zeroth index and when it is final index. So what in this case is for I in the range of spatials, if I is 0, it's the first index, we will consider the bottom, right? Otherwise, we need to consider the spatial I minus 1, and additionally, when it is the last, then we need to consider the top. Take a note that this one, the considerations of the top is another case, because remember in this case that when it goes into the final length, it has two rows. First is the rows to compare to the one before it, right? And to compare if it is not zeroth index 2, and another one is to compare with the top. That's why this is outside of the else. And after we do all that, of course what we need to track is the maximum floors, number of floors. We can start with 0. 0 will be always the lowest anyway, and then at the end we will get it out. So considering the bottom, remember we just need to do the delta there, right? So maximum floor will be max between maximum floor itself with spatial I minus bottom. Otherwise, we need to do the same thing, similar thing, but this will be spatial I minus 1. Finally, considering the top, this will be top minus, oh, don't forget we need to do plus 1 here, because this is between spatial and spatial. So you need to add, not to add 1, you need to eliminate 1 because it is inclusive, right? So these are the three possible branches of logic, and this logic basically make us logically lay it down like this. Now once this is all done, that should be it. Let's just check whether this is correct. So 2946, I think that's the first problem. Yes, and we have 3, right? Yes, that's correct. Let's use example test cases. So it will be 3 and 0, and that was 3 and 0. So it looks correct. Let's submit this. It's accepted. So this is a correct one. Now let's talk about the time complexity. This is a for loop looping for each spatial. So this for loop is representing big O n. And inside the for loop is just a check and a comparison to find maximum and just some mathematical plus minus. So all of this just a big O1. So this cap on big O(n). So in total, oh, we do sorting here, and sorting is a big O log n, right? So sequentially, it will be big O n log n plus big O n, and we will take the worst, which is the big O n log n. So that will be the prime complexity of these solutions. Hopefully that is useful. Thank you for listening in.